Dear students, we are now on video number 2 of the topic Vernier Calipers and Screw Gauge. That is part 2 of 2. Now, in part 1 you would have seen that we discussed Vernier Calipers, uh, including some examples. Now, we have not discussed the zero error of Vernier calipers in that particular video. Now we are now taking the part 2. We are starting with the discussion of zero error on the Vernier calipers, and then we'll follow with the full-fledged discussion on screw gauge. What is the screw gauge? How to find the least count, and then how to take a reading, and also now zero error in the case of a screw gauge. And then plus we will do some examples, practice examples. Okay, now let us now start. Zero error in our Vernier. As you know, now zero error can be positive or negative. Now we just give an example like this. Okay, look at this example. Now in all these cases, it is now the given data is like this: 1 MSD equal to 1 mm, and also now the least count is 0.1 mm. Therefore, with this data now let's just look. Now, when the two jaws are made in contact, you have now, this is now the case 1 when there is no zero error, because now the zero of the Vernier scale and the zero of the main scale are exactly coinciding here. Therefore, there is no zero error in this case. Therefore, if you take an observed reading length of a rod, or let us say like this now, what is now the length of the rod? Now in this case, you are found that it is after 12 divisions of the main scale, you find the zero of the Vernier scale, and therefore this now zero of the Vernier scale is after 12 divisions of main scale, therefore 1.2 centimeter, plus then you find now the third division of the Vernier scale is coinciding with some main scale division. Therefore the reading is 1.2 plus 0.03, 1.23. Since there is no zero error, no subtraction addition is required, zero correction is not required. 1.23. Now you take the case of the positive zero error. What is positive zero error is? Now the zero of the Vernier scale is after the zero of the main scale. Okay. Here, look here. Now the zero of the Vernier scale is after the zero of the main scale here. Therefore, it is positive zero error. Now, just like when you do any measurement, you also do this now like this. Therefore, now it is now, what is now the length which is being measured? Even though the jaws are in contact, you find that the reading is coming to 0 main scale plus, now which is now coinciding. Now the third division is coinciding, third division of the Vernier scale coinciding with some main scale reading. Therefore, it is 0. Therefore, it is now, it's like this. What is now the zero error is 0 main scale reading plus the third division into least count. Therefore, 0.3 mm. Therefore, now zero error is in this case is positive, because after the zero main scale it is coming, plus 0.3 mm. Next, then you put the rod, whatever you want to measure the length, you just put it between the jaws, and you find that the reading is 1.2 plus that is 1.2 is actually 12 mm. I am just putting everything in mm because now this particular example works out in terms of cm, centimeter. We don't want it, we will just put it as mm, because that's more convenient. We are avoiding a lot of decimals. Therefore, now 12 mm is the reading of the main scale, plus what is now the reading which is showing now is now the sixth division of the Vernier scale coinciding. Therefore, it is 6 into 0.1 least count. Therefore, it is now equal to 12.6 mm. Now, then what you do is, now because there was a zero error, positive zero error, always subtract. Zero correction is always subtracting the zero error. 12.6 mm subtract plus zero point 0.3 mm equal to 12.3 mm is a reading. Okay. Next, another example where there is a negative zero error, which is more important because negative zero error is where students get confused because they are taught in a different manner. What is the general manner? What they are taught is like this, that I will tell you, and also then I want you to now follow the method which I am suggesting. Okay. First, let me now teach what is generally being taught. Okay. Now, what is generally being taught is like this. Now, the zero of the Vernier scale, if it is before the zero of the main scale, it is negative zero error. So then what you are asked to do is then find out which division of the Vernier scale is coinciding. In this case, it is given that the seventh division is coinciding. Therefore, then you are asked to actually subtract from the number of divisions on the Vernier scale is 10. Therefore, seventh is coinciding. Therefore, subtract 10 minus 7, you get 3. Therefore, now 3 into least count is 0.1 again. Therefore, zero point 0.3 is the zero error. Okay, therefore now zero point 0.3 is a zero error, and therefore it is taken as a negative zero error is minus 0.3 mm. I just repeat again what you are asked to do by your teachers or for the books generally is for the negative zero error like this. Negative zero error is when the zero or the Vernier scale is before the zero of the main scale. It is negative zero error. Next step is find out which division of the Vernier scale is coinciding with some main scale division. In this case, it is now the seventh division of the main scale is given as coinciding. Therefore, now it is 7. Then next step is, if it is a positive error, then you are not supposed to make any kind of a change. Whereas if it is a negative error, you are asked to subtract that 7th division from the 10 division, which is now the total number of divisions in the Vernier scale. Therefore, 10 minus 7 gives you 3. Therefore, you are said that the zero error is minus there because negative first, and then 3 is the final result after subtracting from 10. 10 minus 7 equal to 3. Therefore, 3 into least count is 0.1 mm. Therefore, now the zero error is negative. I'll just write it here. Zero error is asked to find as negative and then 0.3 mm. Now, what method I am not suggesting is don't make any change in your approach. When you do the positive zero error, what you do? Positive zero error is after the zero of the main scale. That means you are now doing this after zero, therefore 0 plus then which division is coinciding? Third division is coinciding means then it is 0.3 mm. Why? Because 3 into least count is 0.1, therefore 3 into 0.1 is 0.3, therefore after 0 of the main scale plus 0.3 mm gives you positive 0.3. Now, follow the same kind of a method here also. Then the 0 of the Vernier scale in this case is after which division of the main scale? Because it is now after minus 1. Because before the zero of the main scale, which is the division which is there? Minus 1 is there. It may be there, really it will be marked in the main scale, or sometimes it may not be marked. But then usually you would find that the Vernier scale, main scale reading will actually now have a 0 as well as a minus 1 also marked. Because just in case for the zero error calculation purpose, they make it as a minus 1 graduation also would be there. Okay. They may not say minus 1, they just put a mark over there. Before the 0, one more division, which will be actually minus 1. Therefore, now in this case, we just follow the same approach as after which main scale division the Vernier scale 0 is there, after -1. Therefore, now just to do, just like what you have done for the positive error, you take that, therefore -1. Let me just put it. -1 of the main scale, which is -1 mm, plus then which is now coinciding now in this case. Let us say now the seventh is coinciding. Therefore, now 7 into what is the least count, 0.1. Therefore, now this gives you -1 mm plus 0.7 mm, which is equal to -0.3 mm. Therefore, you get directly now a zero error as negative and also -0.3. Now then, you just take observed reading happens to be, let us say 1.2 centimeter is the reading. Then you have to subtract the zero error, 1.20 minus of -0.3, which is equal to 1.23 centimeter. Understood how it is done? If I want you to follow my method, where there will be no question of a change in the method, positive or negative, you just find out after which main scale division the Vernier scale 0 is there. In this case of a positive 0, it is after 0, therefore 0 plus number of division coinciding into least count gives you the zero error, positive. In the case of a negative 0, what happens? Now the 0 of the Vernier scale is after -1 of the main scale. Therefore, put as -1 into what is 1 mm is equal to how many mm? Point is equal to 1 mm. Therefore, it is -1 plus then the seventh division coinciding means 7 into least count is 0.7, that is plus, therefore -1 plus 0.7 gives you -0.3. This is the way I want you to get, because this is actually more important. Now, whatever is a negative 0, generally you would not find this kind of a difficult problem given in the NEET, but you are most likely to find it in the JEE Main and also definitely in the JEE Advanced type of questions. Therefore, be prepared for it. NEET students can actually understand this method, but then they don't have to worry too much about it because they are not likely to get a question of this negative 0 error type. But in case you get it, then you know how to answer it. Whereas JEE Main and Advanced people definitely must know this kind of techniques. Okay. Now this is the coverage for Vernier calipers. Now we go to now screw gauge. Screw gauge is very similar. Only thing is, let me now say, screw gauge is very similar. There you have something called, same as main scale is there, and main scale division may be even much less because 0.1 mm. Okay, main scale division is much less, will be 0.1 mm, or maybe actually 1 mm. Usually it will be 1 mm or even 0.5 mm rather. Okay, not 0.1. 0.1 will no, you will not find it in the screw gauge. 0.5 is generally what you would find. Okay, one main scale division will be usually equal to 0.5. Sometimes it is 1 mm also. Therefore, you should be prepared for it. But they give the data which is set. Then the second aspect is, then instead of the Vernier scale, you have the circular scale. It is also called a head scale. And therefore, then there is something called pitch. Actually, what it means is, when you make one rotation of the circular scale, it advances on the main scale by how many? By how much? Now, in the case, supposing for example, you have the main scale division, each corresponds to 0.5 mm. And then in the circular scale, when you make one rotation means, depends upon how many divisions are there on the circular scale. The circular scale may contain 100 divisions or 50 divisions, whatever be it. Now let me now show you the kind of example. Now in this case, now circular scale is containing 50 divisions, because 0 to 50 it comes to the 50 division circular scale, and then the main scale is having 0.5 because From here to here it is 0.5, another 0.5, another 0.5. Therefore, now up and down you would find on the main scale graduation. Now the center line is called as a reference line. Therefore, now above the reference line, you are given graduations of 1 mm, 2 mm, 3 mm, etc. And then below the graduation, you have this thing as 0.5 mm, 1.5, 2.5, etc. Therefore, now the main scale is supposed to have 1 MSD is equal to 0.5 mm. Now, then the circular scale in this case has got 50 divisions. Therefore, now it all depends upon what is meant by pitch. What is a pitch is nothing but how much one pitch equal to how much the main scale advances when the circular scale is rotated once. That means now supposing when you make one full rotation of the circular scale or the head scale, if the zero of the circular scale comes back after one division of the main scale, then that is 0.5. It just advances by 0.5 mm because one division of the main scale is 0.5 mm. Therefore, pitch is 0.5 mm. Pitch is how much it advances. Then what is the least count is one pitch divided by number of divisions in the circular scale. Now in this case it is equivalent to pitch is 0.5 divided number of division is 50, therefore equal to 0.5 by 50 or 0.01. 0.1, 0.001, no, the 0.01 mm. Okay, 0.5 by 50 equal to 0.01 mm. Okay, therefore now that is the least count in this case. In this case, where the one division of the main scale is 0.5 mm, and then pitch is equal to one division which is 0.5 mm, and the circular scale has got 50 divisions, then it is pitch divided by number of division on circular scale is 0.5 by 50, which is equal to 0.01 mm is the least count. Okay, then very similar, just like the vernier scale, what you need to do it is, now we just put the whatever is the diameter you want to measure between the jaws. In this case, it is not called jaws, it is actually called studs. Therefore, between the two studs, we just keep the diameter, whatever you want to measure, and then take the reading. Now, the reading is exactly like what we have done, after which main scale division you find the vernier head scale. In this case, it's not called vernier, it is called the head scale. After which main scale division, you find the head scale. Therefore, now you find, let us say, now in this case, okay, take for example, now this thing is given. Assuming there is no zero error, we will come to zero error, how to do it. Now in this case, there is no zero error. Why? Because now when now the zero of the vernier, when the two studs are brought in contact, then the zero of the head scale is exactly coinciding with the reference line of the main scale, and therefore there is no zero error. And also now the reference line is like this, and then you find it exactly now coinciding with the zero of the main scale. Therefore, it is head scale is neither advanced after zero nor before zero. It is exactly coinciding with the zero of the main scale. Therefore, there is no zero error in this case. Now, then when you take the reading of the diameter, then it may be like this. Now, in this case, it is given that the reading is after 2 mm, because one division, this is 1 mm, this is 2 mm. Therefore, after 2 mm and then before 2.5 mm. Therefore, now you have to calculate it like this. after 2 mm on the head on the main scale 2 mm plus. Then which division is coinciding with the reference line? In this case, no, 25th division of the head scale is coinciding with the reference line. Therefore, 25 into least count. What is least count? 0.01. Therefore, answer is 2.25 mm is the answer. Okay, now this is about it. Then the next thing is, suppose there is a zero error. Then what happens is, now it is now positive zero error means now the zero of the main scale is visible. In this case, it is now visible here. Now 0 is visible here. Therefore, now after 0, now the head scale is found. And then which division is now coinciding? It is after 0, it is now seventh one is coinciding. Therefore, now the 0 error in this case is now after 0 of the main scale plus now seventh is coinciding into least count, which is equal to 0.07 mm, which is positive because 0 is visible, that after 0, therefore 0.7. Now, and then you do the reading, you take the reading just like this, that after 1 to 2 mm, and then the 32nd division coinciding, therefore 0.3 to 2.32, and then again just like the vernier, you have to subtract that zero error. In this case, a positive zero error, 2.32 subtraction of 0.07, 2.25 mm. Now we come to negative zero error. When you find that the zero is not visible, zero of the main scale is not visible because the head scale is found to be before the zero. Therefore, it is now, just like what we have done, I want you to follow this method, not the usual method what is being taught in your classes or the books. Don't follow that because they ask you to subtract the number and now work backwards. We don't want it. Therefore, we want to now call it as now negative zero error is like this. Again, just like what we have done for the 1 year. Now it is found to be that is zero of the main scale is not visible. That means you take it as a minus. Minus what? Now in this case it is point minus 0.5 mm is your first division. 0.5 mm is your each division of the main scale. Therefore minus 0.5 mm plus. Then which division is coinciding? In this case, in the case of 48th division is coinciding. 48 division. And then what is the least count? 0.01 mm. Therefore, it is minus 0.5 mm plus 0.48. Plus 0.48. This is minus 0.2, or rather 0.02 mm. Okay, therefore this is now the zero error, which is negative 0.02 mm. Then just like you are taking the reading as 2.23 mm. Then again you have to subtract the zero error, minus 0.02, 2.25. Okay, so now this is the way in which you have to approach it. Then for your practice, I have given you enough past asked questions both from NEET as well as from JEE. And as usual, I want the NEET students as well as the JEE students to practice both NEET as well as the JEE PYQs. Because as I told you that the general level of the difficulty of the question what is asked in the past or more or less the same both for NEET as well as for JEE. Plus it will be helpful for the NEET people to practice something little tougher so that they can be very confidently answering the actual question what is asked in their examinations quite fast and easily. Okay. With these words, now wish you all the best and then thank you very much.